So this is chapter 12, video 1, and we're going to talk about chemical kinetics. Chemical kinetics is an application or a facet of chemistry that looks at reactions and how to increase or decrease the rates that they occur. Because you could have reaction processes like changing diamonds to graphite that are so slow that it's barely detectable, but in order for a reaction to be useful for a chemist, it should occur at a reasonable rate. And the first part of this video is going to look at how do you get reactions to go at a reasonable rate. And I have to say that there was a story I heard a few years ago that I thought would be interesting to apply to this. So this is a story I heard from another teacher. And this story talks about a teacher was in school really early one morning and had to make copies, and so their office was at one spot and the copy machine was all the way down a hall that walked past the front door of the school. And this teacher noticed that the student was sitting outside the door, and she had to go and make copies back and forth a few times, and over the course of about 30 minutes the student was still sitting there, which she thought was kind of odd. It's kind of started watching him a little bit more closely, and then saw this girl entering the building, and all of a sudden you could see this boy sparking interest and stood up and started to walk toward this girl. And the boy, all of a sudden, purposefully, you could see, walked into this poor girl, and she dropped her books, and he helped her with it, and before you knew it, a few weeks later, it was prom, or some sort of a dance at school, and he had asked her to go, and they were there together. So this got us thinking about how to get a date for prom and how to apply it to kinetics. And so I'm going to try to give you some tips for how to get a date for prom, so that hopefully you'll get a date for prom, and also remember some different tips on how kinetics works and how you can maximize collisions and get reactions to occur the fastest. So collisions occur all the time. So you're meeting people, you might be colliding with them in the halls, or bumping into them or meeting new people, but they don't always land into getting a prom date. So think about kinetics is you have to have a collision occur, and you have to have it at the correct orientation and with enough energy. And that's what we're going to look at a little bit more closely in a second. But on this slide you can see not all collisions lead to prom dates, and a minimum amount of energy is needed. We're going to call that minimum energy threshold energy, and it must have proper orientation as well. And here's, just to be funny, is a few of your science teachers in the building and their prom pictures or wedding pictures, whatever they sent me. So hopefully you can guess who's who, and I'll ask you in class when I see you. This PowerPoint's found on the Google site under Chapter 12. You can also download the notes for this particular PowerPoint as well and follow along. And here's your chemistry dating graph. So you can see that there's a certain amount of energy that needs to occur, and we're going to call that the meet, fall in love energy, and then you get married and you live happily ever after, and you sort of have this plateau. This is the activation or threshold energy. So ways to get more prom dates. Some ways that you could get more prom dates is to shorten passing periods. If you shorten passing periods, then you would have to move a lot faster through the hallways, and you probably have a lot more collisions happen, and hopefully more chance to meet that prom date. You could also shrink the halls, so less space, and you'd force students to, again, have more collisions moving through the hallways. Another idea would be to bring in more boys or girls from other schools, so you have more of a chance to meet people and have that prom date. And then, of course, if you've ever noticed, boys, that girls like to travel in packs. And when they travel in packs, it's hard to get to that girl that you want to ask, especially if she's in the middle of that pack. So girls should not travel in packs. You should walk alone and you'll have an increased chance of getting a prom date, hopefully. Lastly, you could play matchmaker. You could introduce someone, a friend, to another friend, and hopefully play matchmaker that way. So if you know how to get a date for a prom, you can understand how to increase the rate of a reaction. How, you're probably thinking, how do you apply those ideas to chemical kinetics? Well, this is the collision model and how atoms and molecules react to each other. Think about the fact that molecules must collide to react. They need a certain amount of energy, and they need an orientation, and the temperature has to be a factor as well. So how do you get molecules to collide more often? Well, you can shorten passing periods. You have to move faster. So apply this to chemical kinetics. If you increase the temperature of a reaction, you can get the molecules to move faster. You can shrink the hallways. How does this apply to kinetics? This is like decreasing or the volume of where the reaction is taking place, and it's also like increasing the pressure. So you're forcing the molecules to interact with each other in a much smaller space. If you put more boys or bus in more boys or girls to the school, that's like saying you're increasing the concentration of the molecules. So you're just adding more molecules and more of a chance that the molecules will interact with each other. The packs of girls idea is the same as increasing the surface area of an object. So if you put a cube of sugar in your coffee, or think about versus a packet that's already been crushed, which one's going to dissolve faster? The packet that's already crushed. So if you have an increase in surface area, that will allow you to have more area to interact with the solvent, and as a result dissolve and react. So increasing the surface area would be like grinding using a mortar and pestle to increase the surface area and to get it to finer particles. Lastly, matchmaker. Matchmaker is like adding a catalyst to a chemical reaction. And a catalyst is like the person who does the matchmaking. And you have to think about a catalyst is something that's added to a reaction that allows a reaction to take place very quickly, much quicker than it normally would happen on its own. And a catalyst is really cool because you can add it to a reaction and it reduces that activation energy, or threshold energy if you want to call it that, and it allows the reaction to take place, but it itself doesn't actually become a part of the reaction. You can always extract a catalyst at the end of the reaction and reuse it over and over and over again, and it never gets used into the reaction, so it's separate. So if you've ever done, and I will do the genie in the bottle reaction where you apply manganese dioxide with hydrogen peroxide, and it will create steam and water will form, and the black little catalyst, manganese dioxide, will be at the bottom, and you can filter that off and keep using it over and over again. And so a catalyst is something that makes a reaction happen faster, but it itself does not become part of it. And this is kind of a diagram of that. Here's your reactants, you add a catalyst, and if you add a catalyst, you can see the activation energy is lowered there, and you create your products. Without that catalyst, you'd have this high threshold or activation energy that would have to be overcome, and a catalyst just changes that and makes it happen much faster. This video is not coming out, so this might be a good place to stop anyway for this first part. And hopefully you guys have followed along with your notes, and you have, in general, an idea that you need collisions to occur. Two molecules or three or however many are going to react with one another. They have to collide. You have to have the correct orientation for those molecules. And not all collisions will lead to prom dates, so you're not going to always have a reaction take place. There has to be a certain amount of energy and a certain orientation. And in order to get more of a chance of a reaction to happen, or think of it in terms of how 5 different ways you can do that. You can shorten the passing periods, make the molecules move faster, or the kids move faster in the hallway. This is equal to just increasing the temperature of a reaction. You get the molecules to move faster, they're colliding a lot faster, they're hitting each other, and hopefully you lead to more reactions happening. If you shrink the hallways, that's like decreasing the volume and increasing the pressure of a reaction, so there's more increase in the probability of those molecules seeing each other and colliding with the correct orientation. You could bring in more boys and girls, so you're increasing the amount of molecules that are in the reaction. The more molecules you have, the more likely they're going to react. And lastly, you can think of surface area. So surface area is like creating the particles to be finer, and so there's more chance for the solvent to interact with them. And this is kind of like the pack of girls. You want to be more walking around single instead of in a group. Lastly is the catalyst, and that's like the matchmaker. That just helps a reaction happen much quicker. It lowers that activation energy, and the catalyst doesn't actually become part of the reaction, just lets the reactants interact at a lower activation energy, and doesn't become a part of the reaction. So that's kind of your introduction to chemical kinetics, and then we're going to talk about section 12.1, reaction rates, in the next video.